All right, here we are. Yes, I have sick children again. I'm at the doctor's office again there, ladies and gentlemen. Trust me, I would rather be there with you than in waiting rooms and children and crying and all right. Anyway, so here's what we're doing. The first thing we want to get you guys to do is we want to take a peek at your classwork from yesterday that we finished off with. So go to the classwork. If you need to pause it at this time, go ahead and do that. But we're looking at lesson 2 from yesterday, that question that was on the very back that we just started to talk about that has some pretty big ideas. So we talked about, pause if you need to, by the way. All right. About what happens if I do minutes first and then inches second. Now, the first thing is we talked about is that the minutes first is the preferred way because the minutes when you graph is always on the x-axis. So we're going to get more specifically into this later on in this unit. We're going to see things like independent and dependent, and the main thing to keep in mind is what did you start with here. So as the minutes go by, that's when the tub fills up. That's kind of the idea behind it. But anyway, we get the keyword minutes. So if we kind of fill stuff in there, it's 2 to 3. So if we start filling it in, then we're gonna get a 4, and I 6, 8, 10, 12, 14, whatever. We'll kind of make our table out there. And then again, repeat addition, 3, 6, 9, 12, 15, 18, 21. That's there. So what they want to know is after you set up your table, to write an equation in the form of y equals kx. So they are proportional because again we keep on adding the same thing. We keep on adding the same thing over and over again. And remember, when we solve for the constant, it's y divided by x. So if I take the y, which is 3, and put it on top of the 2, I've got my constant, 3 halves. If I grab someone else like 15 over 10, well, again, if you put 15 over 10, put the y on top of the x, you divide by 5, you get 3 halves. So there's your constant. So your equation there is y equals 3 halves x. All right. So the big thing here is, and we can kind of check one of them out. Let's do something kind of nice. Like let's grab the 6 and the 4. If I plug in the 6 for my y, I get 6 equals 3 halves times whatever x is, and x is 4. So what they're saying is if I multiply 3 halves times 4, I'm going to get 6. So little oh my, cross division, 6 over 1, which is 6. Yay, it worked out. Okay, so what happens if I flip it around? All right, what if I set up my table and I put my inches on the top and put my minutes on the bottom, and I called this the X and I called this the Y. All right. Well, okay. First of all, no, we wouldn't want to do that there simply because of the idea of times always on the X-axis. But let's just say that we did. It actually works out just fine when it comes to solving. So your minutes here is, it's still 2 minutes, 2, 4, 6, 8, 10, 12. Your inches there, just like before, 3, 6, 9, 12, 15, 18. If we do the y divided by x, then look what we get. Y is 2, x is 3. Oh, wait, I get 2/3 x. That's clearly not the exact same thing as my equation here. But watch what happens. All right, let's grab the 6 and the 4 again. This time I'm saying the y is the 4. So I put my 4 down there. All right, and then 2/3 times whatever x is. X is 6 here, so 6 over 1, a little cross division. Oh my goodness, it still works. Okay, so yes, it really does not make a difference when it comes to solving. You just got to make sure what you're calling your x's and your y's, which again, it can come into a problem later on down the road when they tell you who the x is and they tell you who the y is. But in this particular case, it really will not make a difference. That's there. Okay, so we want to get on into your entrance slip here. So if you need to pause, get your purple packet. All right, I'm going to kind of clean things up here when it comes down to it. Oh, I'm going to take the eraser out. Ready? Erase. Woo! I guess you don't have to pause as I'm kind of erasing everything that's there. So your entrance slip that we're after. If we look at what you got there is number of roses, price per dollars there. When they don't tell you who the X is and who the Y is, you can still kind of interpret. Remember, the X is what you start with. X is always your start, and then the Y is going to end up being your result there. So the idea is if you go to pay for the flowers, you first start with the number of roses, because you have to put that up there. You start putting the roses up on the register where the register is at, and then the result would be how much does it cost. So you got to pick the roses out, and then they can finally tell you what the price is. So this way you know the roses are your X and your Y. So is the price proportional? All right, to the number of roses. Well, this one's a little bit nicer because let's look at it. There's what do you do to get from a 3 to a 9? What do you do to get from a 6 to an 18? Well, every time you are multiplying by, yeah, you're multiplying by 3 that's going on with it. But now again, we've got to watch our equation that's there. I got to be careful with my y equals 3x. And again, we just have to check what's x here. Well, x we said was the roses. So oh yes, there was 3 roses. If I do 3 times 3, I do get 9. That's just the big thing that you've got to watch for. If you call it the other way around, the x and the y, that's what can cause some problems here. But yeah, that's it. So now we can use it. Find the cost of purchasing 30 roses. So remember, x was my roses, so I'll plug in 30 were my x's. And this is one, oops, sorry. This is one where you might be like, come on, really? Do I really need an equation for that? I agree with you, no. But what we're showing is that if you can apply it in this situation, then you're going to be able to apply it in the ones where it's not as obvious, which is what we'll see there. All right. Oh, I guess I should get my dollar sign there, right? Yeah, there we go, $90. Okay. All right, so let's look over at classwork. I'm going to point out one more thing to you, and then we're going to kind of let you go and finish your classwork. So again, if you need to pause, go ahead and pause the video that's there. Your classwork, what I want to look at is where things are at, like the table wise for it. So I'm going to skip on down past that first set of problems there of are they proportional, and I want to look at question number 4. All right, question 4 there, they're giving you ounces of coffee. All right, ounces of coffee. All right, and then the other thing that they're giving you here is the price in dollars. So price in dollars. So the big thing is well, who's the X and who's the Y? Well, if you go to the store, you've got to weigh the ounces of coffee, and then they can tell you how much it costs. So you're going to kind of see that a little bit. If you flip on over and you look at question number 6, they're talking about for every 5 pages Gil can read, his daughter can read 3. So what's happening first is Gil is reading, which means Gil's going to be the X, and then the daughter can end up reading the 3 pages afterwards, so that's what your Y is. So yeah, so that's what we want to watch for. And again, table-wise, if they give you the table, yeah, it's going to be an X first and a Y that's second, unless they give you something really specific that's there. And again, if we look at parents and children, well, yeah, the parents were first, and then the children came second. So again, you're going to do a lot of that applying. So, okay, that's it. You guys should be working on classwork at this time. Yeah, answer sheets are up there, so you can get things checked as well, too. And there you go, everyone. Giddy up.